Alright guys, we're going to review how to do synthetic division. So let's take a look. Alright guys, to refresh on synthetic division, it's a little bit quicker than long division. It's when we're going to use, it only works when we have something like x plus 7 or x plus 3. Remember, when we set up our long division, we're actually using the actual solution or the 0. So this is actually when x equals -7. So when I set up my synthetic division, I'm going to put -7 on the outside, and then I'm going to use my coefficients. So for the x cubed, it's 1, then I use 1, -44, and -14. Now remember, if you don't have a term, you have to put it in a 0 as a placeholder. But for this one, it has all of them, so the first number comes straight down. We have 1. 1 times -7 is -7. We add vertically. 1 times plus -7 is -6. Now we're going to multiply -7 times -6, and then we get +42. Add vertically, we get -2. And then -7 times -2 is +14. Okay, which equals 0. So our remainder is 0. Now, when we actually use this, or we'll go to rewrite what we have left, we kind of don't use this last term, especially if it's 0. All right, so now I'm going to have, here's my constant term, then I have my x term and my x squared term. So I have 1x squared, or x squared, minus 6x minus 2. Now if this was actually a number, we would write it as a remainder. Like long division, we would put plus whatever it is over that x plus 7 that we started with. But it's 0, so we really don't need it. We don't put that remainder if we don't have one. And that's just the basics of synthetic division. We're going to use it to apply in some different kind of problems, which you'll see in the next couple slides. Which kind of leads us to this next thing, is that we can actually evaluate functions by using synthetic division. Okay, so I can go ahead and do f of 2. So how I do that is I do 2 as my 0. Okay, I set up this synthetic division, so it's going to be 1, -5, and 1. Bring down this first one, which is 1. So 2 times 1 is 2. Okay. Now -5 plus 2 is -3. -3 times 2 is -6. Add those together, we get -5. So when I go to evaluate, what I'm evaluating is, what does that equal? So whatever my remainder is what would happen if I plug 2 into this equation. So let's just double check. 2 squared minus 5 times 2 plus 1, which would be 4 minus 10 plus 1. Well, that's -6 plus 1, which is -5. So you can evaluate a function by using synthetic division. Okay. Now, like I talked about, we can actually use synthetic division to determine if something is a 0, which means that the remainder is 0. Okay, so what I'm going to do is, it's x equals 3, so 3 is going to be my divisor. Okay, so then I'm going to set up this 1, -5, and 1, just like we had. So we bring the 1 down. 3 times 1 is 3. Add them vertically, so I have -2. 3 times -2 is -6. -6 plus 1 is -5. So the remainder is not 0, so that means that 3 is not a 0. So x equals 3 is not a 0. Just a reminder, if the remainder is 0, then it's a solution or a 0 or an x-intercept, however you want to refer to it as. So the benefit with synthetic division is that it goes by pretty fast, and then it also allows us to check to see if something is a 0 very quickly, and then it also gives us the division so that we can check for another 0. So a lot of times they'll give you zeros and want you to find the remaining zeros. So for this one, it gives us that our zeros are -6 and 6. So I'm going to set my synthetic division up. So I'm going to have 1, and then it's missing a cube term, so I need to have a 0 in for that. Then minus 41. It's missing an x term, so I'm going to put a 0 in for that, and then plus 180. Okay. I'm going to go ahead and use -6 to start with. So bring my 1 down, multiply 1 times -6 is -6. Add vertically, we get -6. Multiply, we get positive 36. Add vertically, I get negative 5. Times that by negative 6, that's going to give me 30. Add those vertically, we get 30. 30 times negative 6 is negative 180, is which we wanted because we know it's a 0, so our remainder should be 0. All right, now I can just jump right to another synthetic division problem since I know that one of my zeros is 6. The other 0 is 6, so I have 1. 1 times 6 is 6. That adds up to 0. 0 times 6 is 0. So negative 5 comes down here. 6 times negative 5 is negative 30. And we get that 0. Remember, this last term always gets kind of canceled out. Okay, so now I'm left with, we kind of cancel out this last term, so I have x squared minus 5. Now I'm going to use that, and that's the whole reason why we use synthetic division and it gives us the zeros, is now that we can actually work with the final polynomial that we have here. I can actually solve it by square root method. So I'm going to say x squared, set this equal to 0, move the 5 over. So x squared equals 5, square root both sides. So x equals plus or minus the square root of 5. Okay, now we have all the zeros. Now we don't want to, it doesn't just ask for the zeros, it says write in factored form. So we're going to write these as factors. So remember, our roots were x equals 6, x equals negative 6, and then x equals square root of 5, and x equals negative square root of 5. Now if it wants it as factors, that means we want to set them equal to 0, so this would actually be x minus 6 as a factor. So I'm going to list all these factors. So I have x minus 6. This one would be x plus 6. This one would just be x minus the square root of 5. And the last factor is x plus the square root of 5. And that's our answer in factored form right here. Okay, just one last little thing. Remember, if we have an imaginary 0, the conjugate is also a 0. So negative 2i will also be a 0. So now when we go to do our synthetic division, I know it seems a little weird, but we can start with 2i, and we can put those numbers in 1. There's no cube term, so I need to put a 0, 3, a 0, and then negative 4. Now I go ahead and put my 1 there, so 1 times 2i is 2i. Okay. Then now I'm going to go ahead and do 2i plus 0 is 2i. 2i times 2i is 4i squared. Which, remember, 4i squared, I squared is just negative 1. So I can go ahead and change this to negative 4. Okay, I squared just makes it a negative, or changes the sign. So that's going to be negative 1. 2i times negative 1 is negative 2i. Add that vertically, we just get negative 2i. And then negative 2i times negative 2i is going to give me negative 4i squared, which becomes a positive 4. Right. Now, there's some i's in there, but remember the conjugate is also a root, so we can do synthetic division with that. Start with the 1. That's going to give me negative 2i. That adds up to 0. Negative 2i. Oh, sorry, that's going to be 0 because 0 times negative 2i is 0. That's going to be negative 1. Negative 1 times 2i is positive 2i, which cancels out to 0. Which right away you can be like, oh, hey, I see that all my 2i's cancel. And that's why it being the conjugate being a root also helps us out. So now I'm left with x squared minus 1, okay, which I can set equal to 0. And then I can move the 1 over, so x squared equals 1. So x equals plus or minus 1. And this doesn't want it in the factored form, so we can just write out our zeros as x equals positive and negative 1, and also positive and negative 2i. Right, I just wanted to remind you about what we do with imaginary solutions.